So we are discussing here about the this chapter, transmission of heat. Okay, so heat transmission or transfer of heat generally takes place because of three different factors, three different conditions. That is, it takes place through three different mediums. That is processes. That is conduction, convection, and radiation. Okay, so first we are going to study what conduction is, then convection, and then we'll come to the radiation part of it. So heat is the transfer of heat from one body to another body. These are the different modes through which the heat transfer can take place from one place to the another place. Okay, so for the conduction, here the heat transfer takes place from one particle to the other particle within the atom or within the material, but without dislocating the particle from the equilibrium position. That means if you heat a rod, the the particles inside the rod will get heated up. They will start vibrating in their own place, but they will not leave the place, and that vibration transfers the energy, the heat, to the other particle, and so on. The vibration is carried on forward by the energy is carried on forward by the means of vibration. Okay, here the particles don't change their place, or don't get dislocated from their place, or they don't travel from one place to another. They just vibrate in their own place, and they transfer the energy, the heat, through vibration to the other particle, and so on. The heat is carried on forward. So if you heat one end of the rod, the heat will be generally passed on from one end to the other parts of the rod, and after sufficient amount of time, the entire rod will get heated up. Okay, so in that conduction medium, in this conduction mode of heat transfer, we have different states which comes into different concepts and different states which we need to understand. First is the variable state. Variable state is that is a state in which the temperature at every part of the rod will increase. Okay, that means a particular state in which the temperature at each and every part of the rod will start increasing, and this increase takes place from the hot surface to the cold surface. Okay, the heat will always transfer from the hot to the cold part. Then the steady state, a point will come, or a temperature will come, where every across each cross section the temperature becomes equal. Okay, after some time a point will come where the temperature throughout the entire material will be the same. Isothermal, all points in the rod have the same temperature. That is called as the isothermal state. Every particle is experiencing the same sort of energy, same sort of heat, and at that particular point we can say that the entire material is in an isothermal state. Next is the temperature gradient. So for the temperature gradient, we can define the temperature gradient as uh, it is the rate of change of the temperature between two particular particle positions, between two particular particles, and it is given by the change which in which they have the change in the temperature which both of them will experience will be between the two isothermal surfaces, is called as a temperature gradient. Okay, so in order to find the change in both of their temperatures, we need to find the temperature of the first and the temperature of the second, and the length between them, and that factor is will be given by the temperature gradient. Okay, that is given by theta minus theta 2 upon delta x, where delta x will be the length between them. Okay, for any two particles. So the next part of the transmission of heat is, first earlier we have discussed conduction, now we will be discussing convection mode of the transfer of heat. Okay, in the convection mode, earlier as we discussed, in the conduction mode the particle does not dislocate from its place. So the particle mainly it vibrates in its place, and it transfers the heat energy through vibration to the other particle. So in the convection mode, what happens is the mode of the transfer of heat in which the migration of the material of the particle of the medium takes place. That means the entire material, or the particle from the material itself gets migrated. Okay, that means in the particles which are present in the material, they move from one place to the other in order to transfer the heat to the overall inside the overall material. So there are two types of convections. There is natural convection and there is forced convection. Okay, so in the natural convection process, we can consider the natural convection as just the water, or the ocean water which is getting heated up due to the sun. Also, in this process, for simple example of the natural convection, we have water which has been which is kept for heating, and we have a burner out here. So the water is continuously getting heated up. So what happens out here is, here the water change takes place because of the density, because of the change in the densities. Okay, here firstly the lower layer of the water gets heated up, and that tries to move in the upper part, and the upper cold water, it tries to move in the lower part. So what happens inside the medium, the entire particles are moving from, one is moving from lower end to the upper end, the other one is moving from upper end to the lower end. As a result, the convection takes place and the heat gets spread up inside the entire material. So this is called as a natural convection, which is arises due to the difference in the densities at the two places. Now basically this transfer of the material from the lower end to the upper end, from the upper end to the lower end, because of the change in their densities, it takes place because of mainly because of the account of gravity. So the gravity takes an important part in the natural convections. In the, another type of convection which we have is called as a forced convection. Here we are forcing the material in order to see here the fluid is forced to take up heat from a body, or that is from a hot body. So here there is a hot body out here. Here we are having a heater, and again we are boiling the same water, but here instead of the water getting heated up and then moving upwards, or the cold water getting being moved downwards, we are actually using a pump out here, or a fan, anything which will pump the water, or which will make the water move very fast in order to get it heated up very much quickly. Okay, so here we are forcing the water to be getting heated up quickly, and such convections are called as forced convections. Okay, so the difference between these two forces, between these two factors, that is the natural conventions and the forced conventions, are such that this natural convention will always take place from the bottom to the top, while the force convection, it can take place from any direction, as we are totally pumping the water, or we are totally swirling the water. As a result, it will the transfer, the particles can move from any point, from any direction to any direction. Okay, next, in case of the natural convection, the convection current moves the convection current moves the warm air upwards and the cool air downwards. Okay, as you saw, the warm air goes up, the cool air comes down. That is why heating is always done from the bottom. Okay, next is natural convection is not possible in gravity, as we require gravity for the particles to be moved down and the other particles to come up. Or also it can't be done in an orbiting satellite. The force of our blood, which starts to by heating, helps us in the helps keeping the temperature of our body. Okay, so these are the different factors in which we have natural convections and forced convections. There is a transmission of the heat which is taking place because of the entire movement of the particles inside the material. Okay, so now we come to the third part of this mode of transfer of heat, that is the radiation. Okay, earlier we have studied the two parts, that is convection, convention, and now we are studying the third part, that is the radiation. So in the process of radiation, what happens is the heat is transferred from one place to the other without heating the intervening medium. Okay, so the heat here is transferred in the form of radiation. Okay, you can have the radiation entering your body and heating the substance, or heating the entire material. So here the medium is not required for the mediums is not actually required for the propagation of this radiations. For this radiation, they produce a sensation of warmness in us, but we can't see them. Okay, next is the speed of the radiation coming out, it is equal to the speed of light. Okay, their intensities, whatever the how much intense they are, it is directly proportional to the square of the distance between the point of observation. Okay, next we have two different kinds of mediums, that is the diathermalous mediums and athermalous mediums in this radiation, where some of the mediums will allow this radiation easily to pass through them without even absorbing them, and some of the mediums, they will absorb the partly a part of this heat radiation, okay, inside them. So the diathermalous medium, we can have a dry ice or a rock salt. Okay, so this allows the radiation to pass through it without absorbing them. So even in winters, during the daytime when the sun is up, we the radiation from the sun enters in our body and we feel that the heat, but the surrounding air, it is a diathermous medium, and hence it does not get heated up. Okay, it does not absorb the heat, that is why we feel the coolness inside in the winter season. Okay, next is the thermalous medium, it absorbs the heat, it absorbs partly the part of the heat radiations through it. So we can have mostly woods or metals which get heated up, due to the exposure to the sun rays. Okay, so these are the different types of mediums we can have when it is considered to the radiation part.